name is Lukasz, and I would like to talk to you about this library I wrote for Flutter called Voyager. So Voyager can essentially, you can put your navigation and configuration of your app in one place. Before we start though, a word about myself. So I am a lead mobile architect at a company called YAML. We're based in Berlin, Germany, and we have an app where you can share and sell your photography. I'm going to explain Voyager with a sample app and try to walk you through the basics of Voyager. Next, we would move to code generation part, and last, deep dive into more advanced samples. We're going to start by defining a requirement for our sample app. So it's like not much really. It's hello world, and then it has like this fabulous button with a plus icon, and this icon should take you to the next screen, which is defined in issue 2. And here is like even less things are happening. We essentially have like a big AF icon and a title. And now if we put like these two requirements together, they look like a bullet list point. And it's also like a high-level overview of what your app is doing. And this is put like this on a purpose because it's oddly familiar to YAML format. And this is easily understandable by computers. And this is where Voyager kicks in. It helps you consume this YAML file. At the very top, you have addresses, which define where your screens are. And up next, you define what the screens are made of. So a plugin node is like a feature description, a feature type, and plugin config is like what this feature is actually doing. So you have an icon and a plus. One extra thing you have here is parameter interpolation. So you can take any parameter from the address and put it into the config and have it evaluated in place. In the context of Voyager, I'm going to use like these terms as equivalents because they practically mean the same here. And now I'm going to talk more about like architecture of the system. So a central piece is the router, and every router needs a map. Now, you give a router a path, and it will resolve you to the location you want to go. In Voyager, that's a config, which is part of the YAML, and it's like has all these values. And these values are being transferred to Voyager instance, which is a key value map. And by default, all the values just go over. So if you had like a title, which is a string, it's gonna be put on this under the same field in the Voyager instance. However, that's not always what you want to do. So if we had an icon and it's like saying plus, we want to turn it into something that's like better for use for us. And that's like an icon in the Flutter, like a Flutter instance icon, which you can just embed in your widget space. So let's see how we can write one of these plugins. You start by extending a router object plugin, and then you add what type you want to support. You need to specify what plugin node you're handling, and finally, you need to override a build object method. In this method, we have a router context, which has parameters from the path, and dynamic config, which in our case is a string value. It's here it's going to be plus. So we're just using this plus to return icon instance from our method. Every library has boilerplate, and so does Voyager. And we start by loading our map from somewhere. In this scenario, I put it in assets folder, but it could be loaded from internet or even JSON file. And next up, we need to specify a list of plugins that will let us consume this map. So we want to have a widget plugin because this will convert the text home widget to actual home widget instance in Flutter. And we're gonna include the icon plugin we've just implemented. Finally, once you have the paths, all paths loaded and plugins for them, you get yourself a router. Having a router, we can start using the Voyager embed API. So basically, you pass it a path, a router, and you can just like see the screen amongst your other widgets. Even better, you can drop router altogether and just reference your widgets by paths. In order to be able to do that, you need to provide a router instance above your material app or Cupertino, if that's what you're using. And this will make a router instance available throughout your all app. Speaking of which, here's how you can integrate with it. So you provide an entry widget for your material app, and on generate route, passing like this route generator will allow you to navigate around your app using standard Flutter API, which is this. So I mentioned on the slide, it's dependency injection framework. I mean, maybe it's a little bit overstatement, but what's Voyager is using underneath is provider. So what happens if you pass a path to Voyager widget, this path will be resolved to a config. And when config is being resolved to a Voyager instance. Voyager instance has information which widget should be instantiated, and when this Voyager instance is being provided to home widget so you can use it. And this is how you can use it. So we had like this requirements to implement. So now we obtain the Voyager instance from the context of our widget, and we can populate all the fields in our UI code. And here, like the icon will already be the Flutter icon, not like the plus text. And just like that, we have implemented our first ticket. Ticket number 2, I will leave to you guys. Now I'd like to talk more about code generation and how this can make this whole thing better. So a prerequisite to using code generation is to add a type per each path. The type should be lowercase, snake case, and this will allow code generator to give meaningful names to fields and values it will create. You start code generator in your project by typing this command, and will start watching your files continuously. Or if you just want to run it once, you can add extra parameter. First time you run it, it will create a configuration file for your generator. So you need to go and edit that file. You need to specify where your navigation map is located and where to you want to generate your code to. You can also specify your navigation map in a Dart file. And this works in a way, you just put YAML, wrap it with triple quotes, and the code generator will get it from there. Why would you do that? Well, it works better with hot reload than updating assets. And this is a file you're getting in return. So you have constant values for types and constant values for paths or a function. So for instance, now this manually typed path will become something that can get auto-completed from IDE. And this is great because this means less typos. Triangles are my favorite shape. Actually, this is about test pyramids and Flutter tests, more exactly widget tests. And Flutter is really good at it. And with Voyager, we can take these tests to the next level. You might wonder what has code generation to do with it. So you supply a test target for the generated test code. And what you will get is this class. This is an abstract class with two methods because we had two screens. And it means you need to implement those methods. If you add more screens, this list will grow and will force you to implement more tests. And from every method, you need to return at least one or more scenarios for your screen. The test scenario comes also with a pre-generated helper that helps you to write properly the tests, passing a parameter. And you have a widget tester with which you can do standard UI assertions about the state of the screen. And once you have a concrete implementation of your scenario class, you just casually run it from a test file. And I'm like lazy person, so I try to apply this to the sample project of Voyager. And just by implementing one scenario per one screen, I managed to bump test code coverage to over 70%, which is like pretty great. There is, however, one problem with this code generation thing, or maybe the navigation YAML. It's plain text, so you don't get safety from the compiler. To mitigate this problem, I've introduced the schema, and you start defining schema per each plugin node. So let's start with an icon. First, we say what this icon is in the YAML file. And we do that with JSON draft v7 schema in shape of YAML. And next up, we define what our plugin is returning. So it's an icon. Generator is not smart enough, so we need to tell it where the icon is coming from. And if you do it for one plugin node, you have to do it for all the rest. Luckily, here it's just a string. And once you have done that, you get information that your schema is validated properly, or maybe you messed up somewhere. But the bigger benefit of that is you can start using the generated Voyager provider. It's still using the normal provider underneath, but now it turns the key value map to strong type fields, which also give you type safety. And I think this is like pretty good. How it's done, the Voyager instance is being extended and has like extra getters. The router won't know by default how to create those instances, so we need to specify the Voyager factory, and there's like a generated factory method to do that. Last thing is a plugin step, so it's like a tiny part of code generation which you can apply. Saves you a few lines of code and maybe one place where you can make typo. Essentially, you can just drop using the templated class in favor of something generated and this constructor line. And if you liked what you've seen so far, the Voyager is available at pub.dev. That's the most up-to-date version. Voyager is a widget router for a reason. If we look back at the example from the beginning, you might want to maybe reuse the fabulous button across different screens. And how we can do this is decompose this widget into two and assign a path to the fabulous button itself. And in your code, this is what was before, and now you can just simply put the widget there with the path to it. And if you don't believe me this works, you can check it online. It's probably going to be like the biggest button you're going to see today. And anyway, this is maybe a bit ridiculous. So let's talk a bit more about this fabulous button. Its representation is a plain text, so we can send over the air a new version of it. So maybe if we pair it with remote config and want to test tab conversion using hard icon, we could easily do that. And basically this means just turning this plain text to router path instance and pushing it down down to the router while the app is running. Flutter 1.2 introduced this thing called navigation with argument. And this essentially allows you to put something like a bitmap or maybe a database service that's not really addressable in path. This is mirrored in Voyager embed API. You just supply Voyager argument and put the value in the constructor. And once you're in the widget space, you can obtain that value using provider and then unwrap the value itself from the argument. And this brings me to a little bit weirder concept, which is imagine you have a shoe. It's like a class shoe. So you could map that shoe to a path. And Voyager is good at mapping paths to widgets. So what we can do here now, directly map shoe to a widget without explicitly specifying shoe widget. And we shouldn't probably stop there. We can make it more generic. So why not just map any class to any widget? Okay, bear with me. So we're just gonna map a list of anything to anything. So now we have a duck and a bulb. We could turn it to dynamic list view. And it's really easy to implement using Flutter and Voyager. We need to specify, obviously, the list length, but then the item builder looks like this. So we retrieve item by the index, and then use the item's runtime to supply the path, and use the item itself as an argument to the Voyager widget. And if you're interested more in this dynamic approach, there is experimental library available at pub.dev, so please do check it out. Now let's talk about state management. So any of you have used Block here? So this plugin is made for the Block library by Felix Angelov, which is like really popular in Flutter community. So I will just start with bringing the sample app from that library. It defines like 2 blocks, and they are responsible for handling the counter state by whenever like there's an increment event, the state is being pushed, the new state is being pushed to the UI. The same for the decrement event. And there is the another block which takes care of the theme of the screen. So it can change the dark theme to a light one. And now, with this plugin, you can describe this in your navigation YAML. And so you can put logic in the definition of the screen. And we can also have like initial values for the blocks. So rather than having like a boring 0, you can have like a better number. And you build this plugin using the builder. So what you have here is context and config. Context is like the path parameters. Config here would be number 42. And then you have a repo which allows you referencing other blocks within the scope of the widget. So you could like get an instance of the theme block and use it somehow with the counter block. But you don't need that. All you need is just a config, which is number 42, and you pass it to the counter block. Yeah, I had to modify the counter block example so it would take the number as a constructor argument, but that's mainly the only change I did to the sample. And in your widget code, you can find your blocks under blocks field, and then from there you can find them by types. So you don't use a block provider anymore, you just use Voyager. Also, Voyager will take care of disposing your blocks afterwards. And all of this is available at pub.dev again. Okay. And this brings me to inevitable end of this presentation, but before we go over, I just want to recap like the main points about like why you should choose Voyager. So I guess like the main benefit is having like this navigation map. So it helps you to have like overview of what your app is doing. You can have your app organized in logical pieces, grouped by paths, and newcomers or veterans can just like quickly see where is what. And if you treat like this map also as requirements, like a high-level overview, you can have it synced in your Git repository. So you can track changes across time and space. And very often when your requirements are in Jira, once the ticket is done, everyone forgets what it was about. And there is like no good way in 3 or 6 months just like know what is supposed to happen on that particular screen. If you ever had to implement deep linking or navigation within your app, you get these things basically for free with Voyager. So please do use it. Last but not least, the YAML file is plain text, so you can send it over the internet. If you pair it with Firebase remote config, you can set up A/B tests, change the behavior of your app without changing your code. And if you had like problems with A/B flags that you forgot to remove sometime later, maybe that's like the better way to test new features in the future. All right. Yeah, I guess this is pretty much it. Thank you for coming here, and I hope you enjoyed this presentation. The project is there on GitHub, so please do check it out. Maybe leave a star. It's me on Twitter, and there is a channel on the Flutter community Slack, where if you want, you can post your questions afterwards, or you can ask me now.